So here's what we're going to do first. Piggybacking on what we've done the last few days, we're going to start taking those pieces from the last few days and putting them together, not just the last few days, what we've been learning about geometry 7th grade, last semester, and we're going to start using those pieces to come together to build a hexagon today, a regular hexagon. All right? So what is a regular hexagon? Six-sided.
All sides.
All sides congruent.
Brenna?
All sides are congruent.
Okay, all the sides are congruent. All the angles are congruent. Good. What else do we know?
Same angles.
6 lines of symmetry.
Okay, 6 lines of symmetry?
No. Wait.
Yes.
Only 6?
No. 8.
8? 12? Which one is it?
If you do the lines of symmetry from
Hold on.
vertex to vertex, and then the lines of symmetry from the side.
Hold on. So hold on. One guideline we do have today, you got to speak up. So you just because we can't hear you. So go ahead, say it again.
Okay. So the lines of symmetry connect from the vertex to vertex, and then the side, one side to the opposite side.
What do you mean one side to the opposite side?
No,
Yeah?
I think it's basically saying that for every 2 vertices and every 2 sides, there is 1 line of symmetry.
It's interesting. Does that make sense?
There's 6.
So why for every 2 sides is there 1 line of symmetry?
Because the line of symmetry has to intersect 2 different sides.
Okay. How does it intersect the 2 different sides? Right? In what way?
It could bisect 2 opposite bases if it's a hexagon, but it could also bisect the 2 angles, so that's why there's 6, because there's 3 pairs of opposite congruent bases and 3 pairs of opposite congruent angles to bisect, so that's 6
Is that true?
lines.
Is that true? Okay. So now that we kind of have ground rules or an understanding of what a hexagon is, a regular hexagon is, let's try and use that as well as the tools with the TI Nspire to construct one. But you guys have limitations. You're not allowed to use a shape tool. I think that'd be a little bit too easy. You can only use 1 line segment. 1 line segment to create a regular hexagon. You can use a reflection tool and as many lines of reflection as you want. You're not limited in how many lines of reflection you can use. And you may use the measurement tools. In fact, you need to use the measurement tools to prove that you've created a regular hexagon. And how you use it or what kind of proof that we need is up to you. You're working in groups. So discuss your methods. Don't work alone. You guys are working together. Talk to each other about what you're doing. Be active participants. Okay, go to it. We've got about 7-8 minutes.
First,
So what are you doing to reflect the original lines over a line parallel? So just make the original line segment horizontal. And then now we can reflect
How are you going to do
it
that? You don't have a hexagon.
Yeah, but
to get the other side.
And we're going to create
So now we have 2 sides of the hexagon. And we reflect it over a line that creates an angle of 60 degrees, right?
Because, yeah, you want to create 120-degree angle, so.
anywhere around here, and we can use that to reflect this segment. So by default, they'd be equidistant. And we'd also have a set of angles, which would be the, that pretty much sets it up for us. Wow.
So what are you guys doing?
Should we make like,
We're going to be starting with all the lines of symmetry.
How are you going to do that? You don't have a hexagon.
We're starting with the bases, and we're going to create the line of symmetry belonging to the 2 bases, and we're going to work from there.
What method are you guys using?
we're going to have the line bisect the angle to
Okay, why would you use that?
so that each angle is congruent
We can set
to make a regular hexagon.
How do you know where to place the line of reflection?
anywhere around here, and we can use that
And place it
to
at
reflect
the
this
end
segment.
of the
So by
vertice
default,
to
it'd be
create the next
equidistant.
angle.
And we'd also
Okay.
have a set of angles, which would be the.
Oh, I'm so close.
So then you would make the second line of symmetry
Go.
from the top base to the bottom base.
No.
Try doing it with a segment.
You only need that one line of symmetry, I think.
You don't have to hold that.
Well, because so the way it works is that you know how you reflected it.
Oh, the shift.
We need to make
do it automatically.
it. Then from there on out, it's working with angles because we can connect each of the other like legs
Oh.
to
Yeah, but
to
that
the
would
line of
be-
reflection, and then we just need to mess around with the angles a bit.
Oh.
There's not like an orthodox way to find it. I don't think.
Yeah, last time that happened to me.
Now, what method are you guys using?
We figured out that each angle would be 120 degrees. So, knowing that, you would make, like we did with the triangle, you would make a line of reflection that is 60 degrees from the, like a vertical line, because that would create a 120 degree angle when you reflect it. Because it doubles.
no! Connects to this angle, and we connect that. Make it the symmetry. Then use that.
We might have to move the original line segment after we get our.
When you were changing my mind.
Because
Shift.
I reflected it, and I think that's how it should be.
Kind of,
you
but
see
yeah,
the
that you're
original
gonna have
is
to move
over
that.
there.
So
Okay, I'm
you're
gonna restart.
going to have to move away this, the image away, so that would go.
So after we do the first.
Calculators down real quick. Calculators down. Now we're going to talk like human beings. All right, I know we can get lost in the technology a little bit. All right, so what are some of the methods that we're using? What are some of the methods? Kaliwat, what do you guys want?
Our method was to start off with the base, which is using the first line segment. Then we're going to do another line of symmetry parallel to the first base, and then from there we can reflect it over that line of symmetry to get the second base.
Okay, go ahead.
Okay, so we started off with the line segment as our first base. And then we added in the one line of reflection or line of symmetry. Construction. So this would be our first line of reflection to get the second phase. So we would reflect the first base over the line of reflection.
Okay, let's pause. What do we think about that method? What do we think? Otis?
I would think it works, but you kind of have to know exactly where you're putting that first line of reflection, because if you're skipping over, and if you put it too close or too far away, because since all the angles need to be the same, the two other sides aren't going to fit in on the other side, like on the left and right.
Is that true?
Correct.
Is there a specific distance that it has to be away from each other?
Yeah.
But it can be adjusted later. Since it's a reflection, both sides will change.
Okay, it could be adjusted later. Is that true? Okay, what else do we think? Do we foresee any problems that he might run into? Did you guys run into any problems while you were making it?
Yeah.
Okay, what issues did you run into?
Like, we had like a hard time like reflecting the lines, because when we connected the points, they weren't like, it didn't actually turn out to be symmetric when we reflected it over.
It didn't line up perfectly?
Yeah.
Why wouldn't it line up perfectly? What about this method would prevent those lines from lining up perfectly?
These kind of
Just
eyeball.
that, because they eyeball.
Okay, so,
Because it's not going to be spaced correctly, because they're skipping like to the other side.
okay, so if they don't line up, is that okay?
No.
Why not?
It needs to be a closed figure.
It needs to be a closed figure, right? Otherwise, it's not a hexagon. We can't kind of have a regular hexagon, right? kind of have a polygon. Right? We got to make sure that this is perfect, right? So how can we help improve this method? Who had another method? Because they were all kind of similar. How can we make it more precise, more accurate?
Can we start over?
Yeah?
So we use the shift key.
The what?
We use the shift key to make sure that we pretty much did what they did, but we, since it's a hexagon, we found out the measure of each angle, since all the angles measure the same, and we use the shift key to make sure that the original line segment that we made, that was our original base, was completely horizontal.
Okay, wait, hold it. Now she said something very interesting that would help us to create this hexagon. That all the angles are the same. Is that true? Okay, so how would you find out the measure of one angle of a hexagon?
I have it.
You have it on your what? What formula?
The formula, number of sides minus 2 times 180, or the difference of the number of sides and 2.
Do you guys remember that?
Yes.
You went over that first semester, right? Okay, let's see if we can do that on the calculator. I want you guys to try and figure that out on the calculator.
I already did.
Okay, I want everybody to work together on that. Okay, try and use that formula, right? Use that formula to find out the measurement of each angle.
Okay, so then, I did 6 minus 2, and then I got 4.
Okay, wait, why are you doing that? Just
Because
because you feel like it, or?
it's part of the formula where you get the number of sides and then you subtract it by 2.
Okay, and how do we develop that formula? Using what?
Using, I don't know, a calculator. Wait, what do you mean?
Okay. We use a triangle method,
Yes.
right? And how, okay, now hold on a second. Now, how did the triangle method help us define this formula?
Because the triangle's 180 degrees.
Okay, triangles are 180 degrees. And what?
And all sides are equal.
Okay, so maybe that could help us to construct a hexagon, couldn't it?
Yeah.
What do we do?
We had the method and you could fit all of them in, but there would always be like one point from each triangle in the middle, which would add up to 360. So that's why either you multiply, you do the sides minus 2 times 180, which I think she was doing, that minus 2, since it's going to be multiplied by 180, it's the same as minusing 360. But what I did was 6 times 180 minus 360, which is the same thing.
Bautista, what do you think about that? What do you think?
I'm still confused about it.
Okay, so how could we, let's back up. How would you use the formula to help us to do this construction? What information could you get from the formula to help us do this? Speak up, speak up. Yeah, no, the formula for finding that measurement of one angle in a regular hexagon. How would that help us? How would that help us? Okay, I'm going to give you about 30 seconds in your group to discuss that. What about the formula and finding the measurement of one angle of a regular hexagon would help us to construct a hexagon using this tool? Go ahead.
Because if you could establish one angle right off, I think you could use lines of symmetry and just reflect the angle. Because then it would become, yeah,
Well, because you know what, if you know the angle, then you're good enough to different.
Yeah, I know it's a regular hexagon.
yeah.
Add its 20 degrees total. I know. Add its 20 degrees total. I know.
And if you know the measure, you should get this.
The measurement is
Okay, Camacho. What did your group discuss? How could we use this formula, or the measurement of one angle? Sorry about that. Measurement of one angle to help us construct a hexagon. Go ahead.
We said that since if you know one angle measurement of a regular hexagon, then you would know the measurement of all the angles of a regular hexagon because all angles need to be the same.
Okay.
in a regular hexagon.
So, how would that help you to make one? Using this method and these limitations. How would that help you? Okay?
Because once you know one, you know all of them. Like Joey said.
So what?
So
How does that translate into us using this tool to create a hexagon?
So you only need to make one, and then you can just keep referring.
Is that true?
Yes.
Okay, one what?
One triangle.
Oh, one triangle.
Or one angle. One
Wait,
angle.
hold
one
on
angle.
a second.
Sorry.
One triangle?
No,
That's
no,
true.
one
That's
angle.
true too. The triangle.
Is the triangle two as well?
Yeah.
Is that true? How would you, okay, here's what I want you to do, okay? First of all, Brenna, finish this up. Let's find the measurement of one angle of a regular hexagon.
Okay, so then you can times that by 180, and then you can divide that by 6 to find the measurement of
Okay, so what is it?
120.
120. Okay, we got the measurement of one angle. Here's what I want you to do. I want you guys, these two groups, actually this group right here, you're going to continue Kaliwad's method. All right? You're going to continue his method, okay, using just the line segment, okay, and reflection, and the information we just found out. You two guys, I want you two folks to try the triangle method, okay, like we've done before. How would we use triangles to construct a hexagon? Okay, so go to it. You got about 6 minutes.
No shape too, yeah?
What?
No shape too.
No, don't shake tool. What are you, crazy?
Still using those, like,
Can we still only use one?
Yep, still using these requirements.
Wait, so doesn't it need to be equilateral?
So we just already start off with a segment, right?
Yeah, 2 parallels.
Like, are we gonna start it off with
We're
one
doing the
side?
triangle.
I know, but are we gonna start off with a triangle, like using the segment as a side or as one, like it's normal, like?
Interesting.
Yeah.
Okay. Okay, guys, pause real fast. Pause real fast. We have a question here. Okay. Malialani, how's that? She's just asked. Could you ask the question again? Go ahead.
Do you want us to just draw a triangle with one segment, or could we draw it with the 3 segments?
So she just wants to build her own triangle.
Oh, yeah.
Can she just build any old triangle to make this?
No,
Oh, it has to be an equilateral triangle, doesn't
You have
it?
to use that method.
Right, if it's going to be a regular hexagon, it's got to be equilateral.
Actually, no.
So how would you make an equilateral triangle?
Using the shift key.
Okay, okay. Yes, you can do that, but you still have to use one line segment. Okay? One line segment to make the triangle as well. Okay, go to it. And use the shift key. Right, that's a good point too. I'm going to pause you guys one more time. One more time. What does the shift key help us to do? What does the shift, Bautista?
Make things accurate?
How?
But how?
Yeah, how? Bautista.
It goes in several increments if you move it.
Okay, so what increments does it move in?
15 degrees.
15-degree increments, or what kind of?
Centiturn.
Okay, we talked about centiturns, but what fraction of a rotation does it move in?
1/24.
1/24 of a rotation? Okay, good. All right, so use a shift key. Get more accurate. Go, go, go.
Because he likes a lot.
I know it's
What did I? Oh.
Use shift. Use shift. It will.
Okay, no, I don't understand what I did wrong, so I'm gonna just restart.
Where does these are connected?
Oh no, they are.
They're separated at the bottom, right?
Oh yeah.
What does that mean the problem must be?
That's accuracy.
Okay, accuracy, but what might be the issue?
Yeah, bonus method.
Segments? Is it the length of the segment?
Or the measurement of the angle.
Right, so what's going to happen? What would force the segments to not connect at the bottom?
Because then it's different.
What issue with the
If you
angle?
use that method, then later you're going to have to adjust it. Unless you were super lucky and you made it completely.
What must be true about one of the angles?
Oh, it has to be 60 degrees. Wait.
Right, but what would make it not close at the bottom? What about the angle?
60.8.
What?
If it wasn't, if it wasn't, if the angles weren't all come through it, then it won't connect because it's 3 sides.
Okay, true. So what about the angle must be true to make it not connect?
Oh, it has to be
What?
bigger than the other 2 angles.
Right, good. So it's probably larger than 60 degrees, right?
Oh my gosh.
Good, good.
Okay.
And we almost got it. How do you multiply a triangle?
Multiply a triangle.
Or duplicate it? You rotate it, just rotate it. Keep rotating. Or keep reflecting it on one side until it goes completely around. How do you reflect? You just reflect it on its side.
Oh, you
so you
reflect the
take that
triangle.
one. Yeah, you just take it on one side and then keep reflecting it around until it comes back to get the full hexagon that you want.
Then you're using a different method. We're not using the same method.
Okay, I'm sorry. About these stuff. Great.
Well, your hexagon has vowels.
Finally back on track.
Oh wait. Oh my.
Oh,
Hexagons.
that line
Yeah,
should
this line is
match
not.
up with that point.
Yeah.
No, but you should leave the line because the angle is correct, isn't it?
Yeah, it is.
Then that means that the base should be moved.
God.
Yeah, I got it. Okay, I got it. Okay, so I did the triangle. Now I have to connect all the triangles.
I feel whatever I'm doing is wrong.
Maybe you should just continue it.
God damn, I think I messed.
Just start over.
Oh no, just try to get the other side of the hexagon and then see what happens after that.
I'm starting.
Is that any triangle?
This is.
Okay.
Yeah,
Use the
one.
shift
Okay.
key.
You guys want a couple more minutes?
Yeah.
Okay.
His shift key is not working.
Are you sure that's completely horizontal? Because if it's not,
Fine, I'll just check. I know it's horizontal.
How do you know
Did
it's
it.
because if it's
I
not
did.
horizontal,
I
it's
used the
gonna be
shift
off.
key.
You use the shift key.
Okay.
Use shift. It will.
Okay, no,
Yeah.
I don't understand what I did wrong, so I'm gonna
It's always moving at the last second.
They're separated at the bottom, right?
Nothing too basics.
What does that mean the problem must be?
120 degrees.
That's not
Accurate.
Okay, accuracy, but what might be the issue?
Yeah, Brandon's method. You reflect
Segments? Is
the
it the length of the
first
segment?
base first.
I have to do that.
Yeah, that's
Right,
what
so
his
what's going to
method
happen?
was, to
What would
reflect the base
force
first.
the segments to not connect at the bottom?
Because
What
then
happened to the
it's
sink?
different. Because if you use that method, then later you're gonna have to adjust it. Unless you were super lucky and you made it completely.
What must be true about one of the angles?
Well, that's why I want to use that method.
Right, but what would make it not close at the bottom? What about the angle?
Why can't we just do it?
It makes a 60-degree angle on the
It's not that
base.
it doesn't work, but when I click
Okay,
it,
so
it starts flickering.
where did you measure where we put this?
Oh no, I just made a line of reflection that's parallel to the base, and then later you have to adjust it a little bit. But it's okay. Because what? No one ever said we can't adjust it.
No, but
Why can't you just use a method that will work?
Well, we don't.
Without adjust.
oh, I see what the problem
We
is.
do have a method.
Oh, we do.
Because if
Yeah,
Yeah,
the method
we
we
do.
were doing from the beginning.
But then we'd have to continue off Brandon's method of getting the parallel bases.
Do we
first.
have to reflect the base first like Brandon did? Is that what we're
No,
Oh, okay.
Wow.
no, you don't. Okay, why wouldn't you do that?
Because then you would have to adjust it later.
Yeah.
Okay, is there an easier way to do it?
Yes, that's what I was doing, and then
Because you said we have to use his method, and he already had the two perpendicular
yeah, but we
sides.
could adjust
Oh, no.
it based on the information that we found.
Okay, good.
So
Oh, okay.
I'm doing it again.
Belmonte, did you make it?
So we'll start with his.
Yeah, we'll go with Belmonte.
Still having trouble with the
Okay, then they're going to help you out.
Let's go back to the beginning.
Okay, help Belmonte to do it.
No, segment. Okay. Use the shift. Two.
And then you should make the first line that you're going to use as the line of symmetry.
60 degrees from that horizontal.
So
So that would be 4 movements
rotations
from, rotations.
Why are you making it 60 degrees?
Because if every angle is 120 degrees, you want the line of reflection to be a 6 degrees angle with the base, because then the angle created with the base and the image would be 120
Okay.
degrees.
Belmonte, go ahead.
So
One,
two,
three,
I know how to be.
4. We're helping.
and then
yeah.
Okay, so Zach, so what's the measurement of that angle now?
60
Zach?
degrees.
Zach, what's the measurement of that angle?
60 degrees.
60 degrees, and you know that why?
Because I was holding shift, it made shift enables you to move in a certain intervals.
Good. Okay, so what? Now you've got a 60-degree angle. How does that help you?
Because since each angle is 60 degrees within a hexagon to form, since each angle within a hexagon is 60 degrees, it would all add up to 120, right? So, no.
So wait,
After
do we agree with what he's saying?
getting this confused.
Each angle in a hexagon is what?
Or it has to equal up to 720?
Okay, 720 degrees would be the sum, so that would make each angle of a regular hexagon what?
So that would make every angle within the hexagon
120. Good. So why would you make a 60-degree angle?
It's because half of one. No. Half of 120. 60 degrees.
Okay, so why? So why make it half? Why make it half? Camacho, why would he make an angle that's half of the angle that he wants?
So that you could, because if you're trying to make another side, you need to bisect it, and bisecting means cut the angle in half. So half of 120 is 60.
Okay,
so he's trying to make the side, so he would bisect the angle in half to reflect it.
Good. So what are we reflecting over that line? What are we reflecting over that line? Brenna?
The other side of the triangle, or the hexagon side.
Okay, we're reflecting the other side. Okay, what else are we reflecting?
the angle.
We're reflecting the angle, right? That whole angle is coming with us. So if we reflect 60 degrees and reflect it over the line, how big is that angle going to be? 120 degrees. Keep going. Good job.
So same thing to the other side.
Or you could just do a horizontal from that point you just made. You don't have to do that one.
Why could you make a horizontal?
Because
The line of symmetry.
Yeah, it would be a line of symmetry, which would also, because that's 60%.
Ah, I see.
Yeah.
And what could we reflect over that line?
You could reflect that whole angle there if you wanted to.
Could we do that?
Yeah.
Can we reflect all that stuff?
Yeah, because it's a line of symmetry.
Ah, it's a line of symmetry, so we can reflect that whole thing over. Good.
Just reflect both those.
It's okay.
No, it's not. No, okay, now reflect the other one. Over the same one.
Yeah, I did.
No, the other one. The other one too.
Oh.
And now you... Yeah. And you can use that other line, your first line, to reflect that new one. Right there, because that's also a line of symmetry.
This one here?
Yeah, you can use that to reflect that one. You used it. The one...
Oh, so it's not just bisecting an angle now, is it?
It's bisecting the whole... It's a line of symmetry.
It's a line of symmetry now. Do you guys see that? That this has become a line of symmetry? Interesting. Okay, go to it.
So use that line and reflect.
Yeah. Oh, right.
Yeah.
Cool.
No, the last one you need
Out there. There.
Awesome. Well done. That was great. Good stuff.
Yeah,
Great. Can we measure it?
Okay, good. Now, what's the only part left to do?
Measure.
Prove it. Just because it looks like a hexagon doesn't mean it's a hexagon?
It is a hexagon.
Oh, sorry, a regular hexagon. Thank you. Very precise. Very precise. So, what do we need to measure?
Your angle.
Angles
And the sides.
and the
We
sides?
don't need to measure the sides since we use reflection. We already know the sides are concrete.
Is that true?
Yes.
Works for me. Works for me.
Still new to this.
That.
I don't
No,
know.
you have to click one side, then the...
You,
Yeah, so
Side.
that
Side.
point, then the
You click
middle.
the
vertex
vertex is the
Yeah.
Second.
point.
Vertex second. Second. You click
So
you
just
click
click one
a
to
side, then the vertex, then the other side.
Why would you click the side? You have to click the point.
That's one
It
point.
doesn't have to be the point, you can pick any point on the side.
Just keep going.
Just keep
And
going.
then start from here. And there. You can move on.
There we go. Just keep clicking the side. Vertex. It'll eventually.
You eventually get around to it? Okay, good.
I did click there.
I'm satisfied. It's good job. Good job.